different light. No. What we're talking about here when we're looking at parabolas, you guys have worked with parabolas in the past. We've graphed them, but your original time of graphing and working with parabolas was always in the form of a trinomial. We graphed them like that, where each parabola was either up like a cup or down like a frown, depending upon the value of A. Each parabola had an axis of symmetry. That axis of symmetry split the curve of the parabola into two equal parts. So you had symmetric twins for ordered pairs. You were able to find that axis of symmetry by doing the x equals the opposite of b over 2a. You took that value and found your vertex right here, and we did a lot of work with this. You did this back in algebra. You did it again with me this year. So this wasn't anything new. What's going to be new today is that we're going to introduce you guys to the left and right parabola, as well as the up and down parabola in terms of different letterings. Okay? Now again, every single parabola, whether it is going to be up like a cup or down like a frown, they still have this axis of symmetry. We also are going to have parabolas that open to the left and parabolas that open to the right. What I want you to see here is when you had your standard parabolas that opened up like a cup or down like a frown, this axis of symmetry was always x equals some number, because it was vertical. The axis of symmetry on the ones that go left and right will be what?
Y equals some.
Yeah, it's going to be y equals some number. Oh, I don't want to go into that. This axis of symmetry here will be y equals some number. Now, hey, all right, good. So as we get into this, we're going to write these just a little bit differently. We're going to talk about what's called a focus and a directrix, as well as how we can write up and solve some stuff here. So here's what we're looking at. We're going to have up like a cup or down like a frown. Those are your old-fashioned ones, the ones that we've been accustomed to working with. That's when we had x squared as a term. So we can write it like this. X squared equals 4 times p times y. And that's going to be our new generic form of the equation. Bless you. Bless you. Now again, what's going to be very easy to tell, if that value of p winds up being positive, it's going to be up like a cup. If it's negative, it's going to be down like a frown. Very simple. This value of what's called a focus, this is where things get a little new. Every parabola is opening towards something. This focus always lies on the axis of symmetry, and it's what the parabola is looking at. The parabola is always opening towards the focus. So whether it's up like a cup, it'll be here. It's down like a frown, it's here. If it's going to the left, it's here. If it's going to the right, it's there. It's always encaptured within the curve. Does that make sense by saying it like that? It's always opening in that direction. Think of it this way. It's focusing in on something. You're looking at something, you're focusing your direction. Which way are you looking? Well, I'm looking that way. That's what I'm looking at. I'm looking at this focus. It's the old hat for you because it's all about camera stuff. It's all about lenses. The other thing that happens now is that we're going to have what's called a directrix. A directrix, yeah, I know, it's a little weird. A directrix is a line that is perpendicular to the axis of symmetry. So if my axis of symmetry is x equals a number, my directrix will be y equals a number. Think of it this way. The directrix counterbalances the focus. This distance between the focus and the vertex is going to be the same between the vertex and the directrix. It's going to going to be perpendicular to that part. Those distances are always the same. So every single one of these parabolas that we work with today, every one of them is going to have a vertex at the origin. Everything's going to go through 0, 0. We're not moving anything around yet. We will move stuff around. We will do shifts of all of these curves that we look at in Chapter 10. Chapter 10 is going to have parabolas, circles, ellipses, and hyperbolas. And the first time we talk about all of them, everything will be centered around the origin. But then we're going to start looking at moving them around. We'll add in our h's and our k's. But that doesn't happen until 10.6. Unfortunately, the way with this week going, be only really 2 days, then we have the half day. And a lot of you guys are out on Wednesday because of the AP Euro thing, I think. A lot of you guys gone for an AP practice test. And then, obviously there's no school. Then following week, we have Tuesday. Then Wednesday, Thursday is the testing day. So we have a half day that Thursday. And then we have all day Friday. So in the course of the next 2 weeks, we really only have 2 full days together. Or 4 full days, excuse me. Guess you're really, really sad. So here's what's happening. Every single one of these parabolas that opens up like a cup or down like a frown follows the same pattern. That's the generic equation. The focus and the directrix also follow the same thing. Again, if you think about it in terms of just looking at this being the origin, if this is 0, 0, the focus, what is the x-coordinate for the focus going to be if it's up like a cup or down like a cup? 0. It's going to be 0, and then whatever p is. Okay. And now again, think about it intuitively here. If your axis of symmetry for a parabola that's up like a cup is x equals a number, the directrix can be perpendicular to it. What's perpendicular to x equals? Y equals. But here's the thing. Notice how this was one direction, this is the other direction. Opposite of p. Okay? And that works the same way if your parabola is opening downward, your focus is down this direction, your directrix would be the opposite. So if your p-value is negative, it's down, the directrix is positive, it's above. Okay? It's very, very straightforward. And it works the exact same way if you twist it on its side when you have the y equals ones. What changes with the y equals, this is not y equals, the y squared. Can I go to a fresh one? If I go to a y squared equals 4px, that means it's going to be going left if p is, well, let's do this one, it's less than 0. It's going to the right if p is greater than 0. Okay. So if I'm looking at just a rough sketch of what something looks like, if I'm saying it's opening to the right, it goes through the origin, my focus has to be somewhere in here. The focus for these is always going to be what, comma, what? P, comma, 0. Very good. Shay, put it away. Thank you. And then where would the directrix be? Yeah. Since this is opening going left or right, it's got the axis of symmetry at y equals. So that means your directrix is going to be x equals the opposite of p. When it's at the origin, yes. Yeah. It'll always lie on the axis of symmetry of the parabola. And since we're at the origin for these to start with, it will have 0 for y. Okay. Likewise, if it was going up or down, it would be 0 for x. until we get to 10.6, and then you guys really gonna hate it. All right. Again, that directrix is equidistant from the origin, that vertex of the parabola. So let's graph one, see what this looks like. X equals negative 1/6 y squared. Let me get you some graphs. Take a couple sheets, have one for your notes and one for homework. You'll probably, I think it's like 4 graphs tonight, something big. And Daisy, you guys would you hand some of the knuckleheads over there? Thank you. And believe it or not, you're going to find that doing these problems are relatively straightforward. There's not a lot of scariness involved. Also, as you get into this chapter, you guys should be pleasantly surprised that it is a lot easier than trig. And why is it easier than trig? Because it's not trig. Well, what chapters were trig? 13 and 14, right? This is chapter 10. Do you know anything about trig yet? Not according to the book. Yeah, well, it's April, Chicago, what do you guys? It's just, what are you gonna do? It was 80 degrees on Saturday and then it snows today. I just love it. It's just hysterical. It's sad. Just take 2. I mean, that's should be plenty. So let's take a look at this, guys. When I have this problem here, I have x equals negative 1/6 y squared. Now, right off the bat, which variable is squared, x or y? So that means this one's going to open which direction? Left. It's going to go left or right because it's a y squared. And if it's going left or right, what's going to help me to denote which direction is going to go? The negative. Since it's negative, which way does it go? Left. Okay. Here's what I do whenever I do these problems. The first thing I do is identify the direction. It's very, very easy to do that. We notice that we have a y squared, and it's negative. It's moving left. I just put a little curve next to that, so that way I know when I go to make my graph, I know what it's going to look like. Now, the next thing is I want to write out the generic form. Y squared equals 4px. The generic form of this equation has y squared by itself. How do I get y squared by itself when it's negative 1/6 times y squared? Just multiply by negative. Yeah, you're divided by negative 6. Multiply by negative 6. Are we okay with that? So if I multiply this stuff both sides by negative 6, I get negative 6x is y squared. And I'm just going to flip it around and write y squared is negative 6x. Just a little bit, since I'm used to writing it like this. Everybody okay with that? Mm-hmm. Now, we are correct. We've got a negative value, so it's moving to the left. The origin for all of these problems today is always going to be at 0, 0. So the vertex for every one of these is always going to be at the origin until we start worrying about our shifting. Won't be till the end of the month. Yes, sir?
When you get p, you have to divide.
Yeah, and that's the next part I'm going to do here. What happens now is that if you notice how we set this up, everybody see how 4p is the coefficient of x? In the generic equation, but yet negative 6 is the coefficient in our problem. That means in order to figure out what p is, we set them equal to each other. So p is negative 3 over 2. Are we okay with that? Negative 6 over 4 is negative 3 over 2? Okay. Now, I know enough information to do everything. My value of p is negative 3 over 2. That means my focus for this problem will be at negative 3 over 2, comma 0. Because I'm following the rules of a y squared parabola. So I put it negative 3 over 2. There it is. My directrix, yes? The original, this is the generic form of the equation. So what I'm doing is I'm setting these two equal to each other. You might have read your book. But yeah, that's where it comes from. We take the coefficient in the problem set equal to 4p to solve for p. Okay. Yes, sir.
How was it that you got -6? Because you said you multiplied by -1/6.
No, I'm just multiplying by the reciprocal here. Just to get y squared by itself. Okay. So if my focus is at -3/2, that means my directrix, since this is a y squared problem, we'll have an equation of x equals, well, what's the opposite of -3/2? 3/2. Okay. Now we have one last thing to look at. We need to decipher how wide open or how narrow the curve is going to look. We use our calculator. Now, in your calculator, what I want you to do, go to your y equals, and right now we have the following equation. We have y squared equals -6x. Our button on our calculator is y equals. How do I get y equals out of this? Square root it. So in the y equals, just type in the y equals the square root of -6x. For what values though? Is everybody getting the top? Getting that piece there? Now when you look at your table, you're right, you're getting error. And why are you getting error at positive values? Because it's the square root of a negative. And why are you getting okay values when it's negative? Because you have -6 times negative something. So you're getting positive values. Okay? Now, by doing it this way, it's just giving you the top half of that parabola. It's giving you just the top part of it. If you wanted to get the other part of it, what else would you have to graph? Think about what you do when you took a square root over an equal sign. What do you have to do? Plus or minus. So you'd have to type in also negative square root -6x. But do you really need to? No, because they're going to be symmetrical about each other. They're symmetrical about the line y equals 0. So what we want to do here is just scroll through to find some number that works cleanly. 0, 0. Yes, 0, 0 works fine. Okay. -6, 6. Are we okay on that? All right. So I know that when x is -6, it's +6. Which means at -6, it's also -6. And that gives me a rough idea of what my curves look like. Okay? That is the directrix. It's the counterbalance of the focus. Now, correct me if I'm wrong. You know this by knowing lenses. If the focus is further out, it's more narrow band, right? The focal point is further out, you narrow the band. If it's closer in, it gets wider. Yeah. That's exactly what's going on here. As this value, the focus itself gets closer and closer and closer to the vertex, you're going to get a wider parabola. If it's further out here, it's going to be it's going to be closer in. And that's has to do with photography and junk like that. I don't know anything about it. I press a button and it zooms. I don't know how to do anything with it. I need to take a class.
It's like you press a button and then you're clicking and it flash.
Well, I know, but how to take nice pictures. It's like,
That's how you make
what's that?
pictures. You need to do it.
I know. I hear it's on the internet
I
now.
can make it.
So, what we're looking at here, guys, is nothing more than setting these things up. What we're going to be able to do with some of these things when we start working more and more with the parabolas is that if you wanted to get really, really fancy, this is what they did on Mythbusters by doing the Archimedes mirror, trying to burn down houses with it. I don't think it did.
No, it didn't.
There's a problem in your book that talks about how you can make a solar-powered hot dog cooker.
I already made one of those.
I think it would be kind of cool to try that. I think we might actually have to do that. It does seem very impractical because they have, microwaves, but you never know. So, yeah. Let's try another one, okay? So this is x equals 3/4 y squared. All right. We'll try another one, and then I'm going to try and do the weird stuff with you guys, because there will be a little bit of weirdness here. So I have x equals 3/4 y squared, which means which direction is this one going to go? This is moving to the right. Everybody okay with that? All right. What's that? I know, yay. Now, we need to get y squared by itself. To get y squared by itself, we get y squared is going to equal 4/3 x. Is everybody okay with that?
Yeah.
So now, what's that? I just multiply both sides by the reciprocal. Now, again, I go to my y squared equals 4p times x, which means I set these two equal to each other. So p is 1/3. Okay. So the value of p gives me 1/3. So that means my focus is where? And my directrix is where? Notice how your focus and the directrix have the same coordinate. The focus deals with x in this problem, then the directrix is at x equals. That's because it's a y squared problem. That's because it's a y squared. And again, when we go to graph this, and fortunately it's just going to be kind of crummy because it's my origin is at 0, 0. Go put that in your calculator again. Thanks, God.
She's being racist.
And then to get a clean point somewhere.
You would get
Yeah, 3, 2.
3, 2? Yep, there he goes. So you have a clean point at 3, 2. And me at 3, -2. Okay?
So, wait, you plug in y equals square root of 4/3 x?
Yes, sir. That gives me the top half of the curve. I could type in negative square root 4/3 x if I wanted to, but there's no point since these are symmetrical. You don't need to worry about that. You get your one set of one clean ordered pair at 3, 2. So that means it's still going to be on that same x coordinate. It's just going to be at -2. Okay? Yes, sir.
Where's the focus and direct?
What's that?
Focus and direct.
What are the focus and the directrix for? What happens is that every point on this curve is always going to be equidistant to the focus, and it's always going to be equidistant to the line of the directrix. No matter where you go, I got a better diagram of that. I never really go through a lot of that. Oops, I lost it. Every point on this curve, they are always equidistant to the focus. Wherever you draw the focus, you're going to get the same value. What this allows you to do is that means that when you're trying to get light, refraction, or reflection is when it's going into it. Refraction is outward. So when you're trying to hone in like solar power, you move this value up and down so that way it brings the parabola in and out to be able to point it in a certain direction. All right, yes, sir?
Back to the problem.
Yeah.
My calculator won't put fractions in for the y equals again.
Huh? Is it not, did you do alpha y equals?
Yeah, and it won't do anything.
Okay, give me a second, Brett. Yes, sir?
Wouldn't any point on the point on the line of symmetry be distant from any opposite view to?
Yes, it would be, but what happens is that all points on the parabola are equidistant to just the focus, just that one singular point.
Would they be equidistant to any point on the?
No, I'm talking about, but this point to the line of symmetry isn't going to be the same as this distance to the line of symmetry here and here. These values are not the same. You're talking about to the symmetry line, but I'm talking about this point and its twin is going to be equidistant to it. I see what you're saying.
But the,
I know,
the
yes.
closer one is equidistant.
I see what you're saying.
But the
Yeah.
I still don't get it.
No, I know what you're saying here.
The closer one is equidistant, the only the opposites are equidistant.
Oh. The points between the focus to the line and then the line, or focus to the curve is going to be the same distance from the curve to the directors.
90 feet
That's
below the y value of the point will be equidistant to each other.
No. Again, let me redraw this.
Okay.
These two values are the same.
Yes.
This point from here to here is going to be the same as here to here. That's what I said it backwards.
I get it.
Okay. You were correct in saying isn't every point
I
on
thought you
that.
were saying that.
I did, and I forgot about the bringing it down to the directors.
Got it.
That's why I was.
It's math.
Fantastic.
I typed this into my calculator and it gives me a straight line.
You did it wrong then. Oh, because the square root isn't covering the x.
Oh,
That's why. You got out of it too fast. There you go.
Wow.
You're right. It should give you a straight line for that. 'Cause you had 2, 3.
Wait, so Friday's a half day too?
You can tell me.
Sorry,
Let's try it. Yeah, go ahead. I'm sorry. What? Okay. Glad I can help. Let's get weird now. Let's write the equation in standard form with the vertex 0, 0. All these are going to have is the vertex at 0, 0. And the given directrix at y equals 2. Which means I'm going to write it in one of the forms of x squared equals 4py or y squared equals 4px. So what I want to do is if I know what my directrix is, knowing what the directrix is will now allow you to figure out what direction your parabola is going. Here's how you do this. First thing you want to do when you have a problem like this is just draw a quick XY grid. Okay? When I draw a quick little grid, I now can plot where the directrix goes. The directrix is y equals a number. Is that horizontal or vertical? It's horizontal.
So yeah,
Up and down. How's horizontal up and down?
no.
Oh, the parabola.
And below the horizontal.
Okay. So I know I have
It's Monday.
yeah, after a 2.5 day weekend. So my directrix is there. No, I know that my origin, the origin is the vertex. The directrix is always behind the vertex. So that means this has to be opening this direction. This distance is 2, so that means this is -2. we don't have to find any points because we don't have to graph it. What we have to do is write the equation. So I know that this is going to be an x squared parabola. But what I need to do now is that since it's an x squared parabola, because we were able to tell that the directrix was above where the vertex is, it's opening downward. That means that the p-value is going to be what? It's going to be negative. So think about what the directions tell you. Well, our directrix for this style is y equals the opposite of p. Well, here, y equals 2. What is p then? Very good. That means p is negative 2, which means I take this with this and go x squared equals 4 times negative 2 times y. And I'm done. By visualizing where it's going, it's going to help you out real fast. Okay? Especially if you get in the habit of trying to do that now before we start worrying about shifting. As we start worrying about shifting, it gets kind of messy. Okay? It will get kind of messy. It's x squared equals 4, is it 4p minus h y plus k? There's a lot of nasty stuff. All right. Let's look at another one like this. Again, I have a focus at negative 6, 0. My vertex is at 0, 0. So I'm going to figure out which direction this is moving by putting in an XY grid real quick and plotting it, see what it looks like. So when I put in an XY grid, my focus is at negative 6. If my focus is at negative 6, which direction is this curve going? Left. Forward. That's the best answer I've heard all day. It's got to go this way. Is that going to be an x squared or a y squared parabola? All right. It's a y squared parabola, so I know it's going to be a y squared equals 4px, which means that p, bless you, with the vertex at negative 6, 0, isn't that p and 0? So what's p in? Negative 6. So I get y squared equals 4 times negative 6. That's correct.
On that one.
Okay? So what's going to happen here is by doing a quick sketch of the graph, you're going to be less likely to make a bonehead move with your signs. Okay? And I mean signs by S-I-G-N-S, not S-I-N-E-S anymore. Okay? Positives and negatives, not waves. Okay? Questions? Yes, sir.
What do we put into the calculator
For the graph?
Yeah.
The only thing you're putting in the calculator for the graph is to get one set of symmetric twins. Everything else you can chug out by hand.
Okay.
Okay?
Yeah.
Do those, please. I think there's like 4 graphs. Every other odd, yeah. Most of these problems, guys, are asking you to identify what the focus is, what's the directrix. There's only, I think, 4 of them that are graphs. And then there's a couple of them that you have to write the equation given a directrix, write the equation given a focus. So it's every other odd. It's not that many.
No, it's like 12.
Watch someone
It just
just
looks
like
scary.
every
It does. It's very scary. Where in middle school they're like, oh yeah, do legs can